mathematicians, this is lesson 11.1, simplifying radicals. This is kind of confusing. We are getting towards the end of the book, so it's going to keep getting harder and harder. Simplifying radicals are anything with a square root symbol. So the multiplication property of square roots, if you look at this, I can take the square root of 54 and I can separate it into the two factors of 54. What that does is that allows me to look at what the factors are, and if any of them are perfect squares, I can simplify them. So if you look here, the square root of 9 is 3, but the square root of 6 I can't simplify. So what they do for the answer is they say it's 3 times the square root of 6. So that's what we're going to be doing. So let's take just some little vocab to remember. Okay? The radical is actually the square root symbol. That is the radical. So make sure you write this in your notes. The radicand is whatever is under the square root, and the index is the number. We're pretty much just sticking with squares, not cube roots, but you will see cube roots in the future. So make sure you have this written down. Okay, so simplify each radical expression. So the square root of 50, if I put that in my calculator, I can simplify that and get an irrational number. However, I don't want that. I want something more exact. So the square root of 50, I can break it down into the square root of 25 and the square root of 2. I'm really trying to get everything to match my perfect squares chart. So the square root of 25 is on my perfect squares chart, and that's 5, and the square root of 2 is not. So it would just be 5 square root of 2. That's your answer. So try this next one. Okay, so -5 you don't touch because that's just out there. That's its own number. So the square root of 300 I'm going to break into the square root of 100 times the square root of 3. Now, I know that the square root of 100 is 10, so I can rewrite this as -5 times 10 times the square root of 3. So -5 times 10 is -50 square root of 3. So it's the exact same thing as this. It's just written in a more simplified fashion. So you're just simplifying it. All right, simplify each radical expression. So now what they're going to do is they're going to throw in some variables. So you're still doing the exact same thing. I'm going to break this up into the square root of 9 times the square root of 3. And then I'm going to do the square root of n squared. Now, square root of 9 is 3. I don't know what the square root of 3 is. But I know the square root of n squared is just n because a squared and a square root cancel each other out. So I'm going to put that on my left side, and then the square root of 3 goes at the end. So 3n square root of 3. So try this next one. Okay, so -a goes out front. Now 60. I want to break that up into two radical expressions. Now, I don't want to use 6 and 10 because neither of them are on my perfect squares chart. So you have to think, okay, so 6 and 10, 2 and 30, that wouldn't work. 4 and 15. So the square root of 4 is a perfect square, so I can do that. Now, the square root of a to the 7th. Now, I don't want that because it's not simplified at all. But I know if I have a squared, that will cancel each other out, and then a to the 5th. So, now let's see what we can simplify. -a we can't simplify. The square root of 4 becomes 2. The square root of 15 doesn't change. The square root of a squared becomes a, and the square root of a to the 5th doesn't change. So now I'm going to combine my terms that don't have a radical sign. So I can combine this, this, and this. So 2 times a is 2a, times -a is -2a squared. And then you have under your radical is 15a to to the 5th. So kind of a crazy answer. Okay, next we have simplify each radical expression. So this is pretty much the same, but we're doing the reverse. So if you have the square root of 13, the square root of 52, neither of those are perfect squares. So what you do is you multiply these two together. So you do 13 times 52, which equals the square root of 676. Now from there, you just reduce that. So I say, okay, can that be divided by 4? Yes, it can. So it would be the square root of 4 times the square root of 169, which the square root of 4 is 2 and 169 is 13, so my answer is 26. Here it's not so easy, so I have my 5, I leave my 5 outside, and then under I'm going to have 3 times 6, which is 18, and c times c is c squared. So then I have 5 times the square root of 9 times the square root of 2 times the square root of c squared. I broke that into 3 different terms. Now this one cancels out to 3 and this one cancels out to c. So I would have 5 times 3 times c times the square root of 2. 5 times 3 is 15, c square root of 2. So it's like a puzzle. You have to just try and figure it out. Okay, now we have to simplify radicals involving quotients. So if you look at this, if they have a radical sign and then inside of it is a fraction, you can separate that radical sign and put one on the top and one on the bottom and do them each separately. So it's pretty much the exact same, but you have to do it twice because you have to do your numerator and your denominator. So it says, the radical expression is in simplest radical form when all 3 statements are true. The radicand has no perfect square factors other than 1. The radicand, remember, is this number underneath, the 25 and the 16. The radicand has no fractions, so you can't have a fraction under your radical sign. And the denominator of a fraction has no radical. This one's key too. The denominator cannot have a radical sign. Okay, so let's try some. Square root of 144 over the square root of 9. This one's kind of an easy one because we know the square root of 144 is 12 and the square root of 9 is 3. 12 divided by 3 is 4. Super simple. Now this one is not so much. So if I break this up, I'm going to rewrite it, and I'm going to write the square root of 25 times the square root of p to the 3rd all over the square root of q squared. Okay, so these two I can immediately cross off because they both simplify. This becomes 5 and the numerator becomes q. Okay? The square root of p to the 3rd I can simplify even a little bit further. So what I can do is I can say, okay, 5, the square root of p squared times the square root of p all over q. I just separated this q to the 3rd into a squared and a p, just single. So then this cancels out and becomes just p. So then I have 5p square root of p all over q. I don't have anything in my denominator, or a radical in my denominator. I have a whole number or a letter variable, and it works. So that is it for your notes.